All right, ladies, what I would like to do for your snow day activity is really just review a concept you've already learned that seemed a little bit unfamiliar when we left for a break, and that was addition and subtraction with rational expressions. So I'm going to call this section 5.9. It's really a review. What I'm going to ask you to do is pause this video now, take out your notebooks. You're going to spend about 5 or 6 minutes taking some notes. And then I'm going to ask you to spend about 20 minutes doing some practice. So I will post that for you. So we're going to call this 5.9, and it's adding / subtracting rational expressions. Adding and subtracting rational expressions. Okay, so my question is how can I add something like 1 over x plus 4 minus 2 over, let's do x plus 3. So can I rewrite this expression as really just one single rational expression? And how would I do that? Well, what's nice is that we have strategies from fractions that will help us with this problem. I'm going to relate it to adding together a quarter plus a third. Quarter plus a third. We know that the size of a quarter is about that big, and the size of a third is, I don't know, about this big, right? And you learned in elementary primary school that getting an exact value of a quarter plus a third is not easy unless you break up these pieces into the same number of parts. All right, so that's really the concept that you learned in elementary school. And we do this by multiplying this fraction by 4 over 4 and this one by 3 over 3 to give us a common denominator of 12. And then we learn that there are 3 parts for every 12 in a quarter, and there are 4 parts for every 12 in a third. And now that we have broken them into like the same unit of measurement, we can count up how many parts we have. We have 3 parts plus 4 parts is going to give us 7 parts out of a 12-parted pizza pie kind of thing. All right. So this idea of multiplying by what's in the opposite part of your denominator is the concept that we use for adding and subtracting rational expressions. So similarly, I'm going to multiply this rational expression by an x plus 3 on top and bottom. It's not changing this fraction at all, because essentially this is 1. But what it's doing is it's giving me new parts in the denominator, so that way I can actually combine these two things together. So this guy is now going to be multiplied by an x plus 4 on top and bottom, x plus 4 on top and bottom. And now it just takes a little bit of algebra. I'm going to distribute the 1. That gives me x plus 3. I'm also going to distribute the negative 2. So this is a negative 2x and a negative 8. Okay, so that's an important concept there. And it's going to be over one common denominator, right? So I'm counting up these parts over my common denominator of x plus 3 times x plus 4. I'm just going to bring this back. Recall here, we're counting up the parts, right? 3 plus 4 gives me 7 over our common denominator, right? So that's why I only have 1 now, right? It's like I'm combining together these numerators over one common denominator. Make sense? And I'm just going to simplify this. This is essentially the answer. I've achieved my goal of getting it as one single rational expression. But now I can go x minus 2x is negative x, and then 3 minus 8 is negative 5. easy enough, over my denominator of x plus 3, x plus 4. All right. I'm going to show you one more example, so we can call this example 1 if you would like. I'm going to show you one more example because sometimes you'll have a rational expression that looks quite different, like the denominators look quite different, but really they have something similar to them. So this one I want to look at, I don't know, 2x over x squared minus 4, and maybe a added to an x plus 3 over, let's go with x minus 2. Yeah, I think that's going to be good. So 2x over x squared minus 4, and then plus an x plus 3 over an x minus 2. So according to this strategy, I would multiply this fraction by x squared minus 4 and this fraction by x minus 2. Combine them together, great. But there's actually something that's in common down here, and hopefully you're noticing that now. Let's just take a look at this expression. Let's see what happens if I factor it out. So if I factor out that expression, I get x plus 2 and x minus 2, right? Plus an x plus 3 over x minus 2. Notice how both these fractions have an x minus 2 in common. That means if I want to make my denominators the same, I don't have to do that much multiplication. I really just have to multiply this fraction by the missing x plus 2. So if I multiply this fraction by an x plus 2 on top and bottom, now notice I have a common denominator. So my suggestion is, if you're given an expression and you notice that the denominator is factorable, see if you have any common factors to make your math a little bit more simpler. All right, so now the idea is really just to multiply out your numerators, combine them together, and maintain this denominator. So I'm going to maintain the denominator of an x plus 2 and an x minus 2, and I'm going to distribute this out. I'll do a little side math up here. X squared plus 3x plus 2x plus 6. Combined together is x squared plus 5x plus 6. So I have a 2x from this guy, plus another x squared plus 5x plus 6. And then I'm just going to finish off this problem by combining my x terms. So x squared plus 7x, right, plus 6 over x plus 2, x minus 2. And so that's really the major concepts with addition and subtraction of rational expressions. So what I'm going to ask you guys to do is to practice this. I'm going to post rational homework number 9. This video took about 8 minutes. So girls, I really don't want you spending more than about 15 to 20 minutes on the homework assignment. Do as much as you can in that time. And then wherever you get to, you're going to say, this is how much I did during that time. And that's what you're going to hand in when I see you guys on Wednesday. All right, have a lovely snow day. And can't wait to see you guys later on this week. Bye, girls.